Welcome to the Explainer. This is where we take really complex topics and, well, make them make sense. Today, we are diving into something called Paxos. It's a fundamental algorithm that, believe it or not, keeps a huge chunk of our digital world from falling apart.
All right, let's just jump right in with a question that affects pretty much all of us every single day. Think about it. When you save a photo or a file to the cloud, it's not just on one computer. It's copied onto servers all over the world for safety. But what happens if one of those computers just crashes, or a message gets lost in transit? How do all the others agree on what the real, latest version of your file is?
And that right there is the heart of the problem. To keep your data from getting corrupted or just lost forever, this whole group of computers, what we call a distributed system, has to agree on one single truth. They have to reach a consensus, even though any one of them could fail at any second.
So let's really dig into this, what's known as the distributed agreement problem, because it's the foundation for so many things we take for granted, from our bank accounts to our social media feeds, and trust me, getting computers to agree is way, way harder than it sounds. Here's why it's so tough. In one of these networks, you can't trust anything. You've got some computers that are super fast, others that are slow. Any one of them could just go dark without any warning. Messages you send might get lost, or show up late, or even show up twice. There's no single clock, no single boss in charge. It is, for all intents and purposes, organized chaos.
Now, to solve this incredibly messy problem, computer scientist Leslie Lamport did something absolutely brilliant. He didn't start with a super dense technical paper. Nope, he told a story. A story about a fictional Greek island named Paxos, and its, let's just say, less than reliable government.
This quote just hits the nail on the head. Right? How do you actually get anything done? How do you pass laws that stick when the people making the decisions are just constantly wandering in and out? This is the exact same problem our distributed computer systems face.
So here's how Lamport's story breaks it down. You have proposers, they're like the legislators trying to get a new law passed. Then you have the acceptors, they're the council members who actually vote on the law. And finally, you have learners, who are kind of like scribes, just writing down whatever law officially passes.
So, how does this shaky parliament actually manage to pass a law without everything descending into chaos? Well, it all comes down to a really careful, really clever two-phase process.
The whole thing really just boils down to these two fundamental steps. First, there's a proposal phase. You could think of this as prepare and promise. And then there's the voting phase, accept and accepted. That's it. Let's break it down.
Okay, so in phase one, and this is the really smart part, a legislator doesn't just shout out their new law. First, they send out a prepare message with a unique number, like asking, hey, can I make proposal number 5? The council members then look at that number. If it's the highest they've seen so far, they send back a promise. And that promise is crucial. They're basically saying, okay, I'm listening to proposal #5, and I promise I won't accept any older, out-of-date proposals that might still be floating around.
Now, once our legislator gets promises from a majority of the council, they move on to phase 2. This is when they send the actual law, like, please accept law number 5, build a bridge. A council member will only vote yes if they haven't, in the meantime, made a promise to an even newer proposal, like proposal number 6. This whole two-step dance acts like a safety lock that prevents the system from ever agreeing on two different things at once.
But for me, this is where the real genius of Paxos kicks in. It's resilience. The entire system is built from the ground up to work even when things go wrong. So what happens when the parliament is total chaos?
What if a council member just disappears? Poof, gone in the middle of a vote. Well, it's actually not a big deal. The protocol doesn't need everyone to vote. It just needs what's called a quorum, which is just a simple majority. As long as a majority of members are still around and voting, the parliament can safely keep on making decisions.
And what happens if two different legislators try to pass conflicting laws at the exact same time? Again, there's a dead simple, unbreakable rule. The proposal with the highest number wins, period. The council will simply ignore the one with the lower number, and that losing legislator has to go back to the drawing board and try again with an even higher number. No split decisions.
So you see, this whole idea of a quorum is the magic key. It's what mathematically guarantees two things. 1, that two different conflicting laws can never be passed, and 2, that a few members failing won't bring the whole government to a grinding halt.
Now, this whole story about a part-time parliament on a Greek island, it's not just a cute analogy.
It is, quite literally, the blueprint for the super robust, fault-tolerant systems that power the global infrastructure we all depend on every single day.
Of course, in the real world, you need to be fast. That two-phase process can be a little slow if you have to do it for every single decision. So there's a common optimization called Multi-Paxos. Basically, once a proposer gets a law passed, they become the leader. And that leader can then just skip that whole Phase 1 prepare and promise dance for all their next proposals, making things way, way faster.
And who actually uses this stuff? Well, it's basically a who's who of big tech. Paxos and its variants are the engines behind critical systems at Google, Amazon, and Microsoft. You'll find it in huge databases like Cassandra and massive storage systems like Ceph. This is absolutely battle-tested, hardcore tech that keeps some of the biggest services on the planet running smoothly.
So when you think about it, one of the hardest, most complex problems in computer science, getting a bunch of unreliable machines to agree on one truth, was solved with a surprisingly elegant idea all wrapped up in a story about a fictional parliament. It really makes you wonder, doesn't it? What other impossible problems are out there, just waiting for the right story to come along and solve them?